In this video, we're going to go through an example of finding the nth term, or the an term, for this sequence. Negative 2 over 10, 13 over 4, negative 16 over 8, 19 over 16, negative 22 over 32, and so on. So the very first thing that I notice is that it alternates between negative and plus. So that tells me this is an alternating sequence. Which means in order to get the alternating of signs, we need to use one of two options. We need to use negative 1 to the nth power, or we need negative 1 to the n plus 1 power. It just depends on which term we want to start to be negative and which one we want to start as positive. Because I want to start it at n equals 1 as a negative number, I want to use negative 1 to the nth. That way when I plug in 1, I get negative 1 to the 1 power. Then that will give me a negative number. If I wanted to start with a positive number, then I would want to make sure I use this option. So when I plug in n as 1, I'm actually raising it to the power of 1 plus 1, which is squared, and that negative 1 becomes a squared, and then it starts off with it being positive. So I know for sure that I'm going to have this negative 1 to the power of n in my nth term. So the other thing that I notice, if I look at the denominator of all of these fractions, just looking at the denominator, I notice that everything keeps doubling. So when you have something that keeps doubling, that means you have a factor of 2. And since I'm starting off with the denominator is just 2, I want this to be 2 to the 1 when I plug in 1, 2 to the first. So I want to have 2 to the n in the denominator. So then when I plug in for the second term, I get 2 squared. That gives me 4 in the denominator. And when I plug in for the third term, I get 2 to the third, which is 8 in the denominator, etc. Those two are the easy parts. Now, when I look at the top to figure out how to get the 10, the 13, the 16, the 19, the 22, etc., when I figure out how to do that on the top, if I notice going from one term to the other, now we're just looking at the numerators, I keep adding 3. I'm not looking at the signs because I already took care of that with the negative 1 to the n power. Looking at just the number, not the sign, I keep adding 3. And when we have a value that we keep adding over and over again, that makes me think of the arithmetic sequence. So to figure out the numerator, we're going to use the arithmetic sequence formula. My A1 would be 10, because I want to start with 10 in the numerator. So let me make a note of this so that this isn't confusing in your notes. This is just to figure out the numerator. Okay, and then the common difference is going to be 3. Because we keep adding 3 over and over again. So my general formula for the arithmetic sequence is my A1, which is 10, plus 3 times n minus 1. Now, when I clean this up a little bit, I get 10 plus 3n. I'm going to distribute the 3n minus 3. And if I put it in descending order, it's going to look like this, 3n plus 7. So then I know that's what's going to go on the top here, so that I can get the 10, the 13, the 16, the 19, and the 22, and so on. I have the 3n plus 7. So let's check it. I want to make sure when I plug in n as 1 for my first term, I get negative 10 over 2. So when I plug in n as 1, that gives me a negative 1 to the first power. And then I have 3 times 1 plus 7 all over 2 to the first. So that gives me negative 1 to the first power. That gives me a negative 1. And then I have 3 times 1 is 3 plus 7 is 10. And then I have 2 in the denominator, and that gives me negative 10 over 2. Let's check the second term. Let's do another one just to make sure. So if I plug in now n is 2, I'm going to have negative 1 to the 1 plus 1. Then I have 3 times 2 plus 7 all over 2 squared. So I'm replacing all my n's with 2 now. So I get negative 1 to the second power. So that's negative 1 times negative 1. That's going to give me a positive 1. Then I have 3 times 2 is 6. Plus 7 is 11. Oh, sorry, 13. And then 2 squared on the bottom, that gives me 4. So then on top I have 13 times 1, which is 13 over 4, and that's positive. And then if you want, you can keep going to check to really check the other terms, but it seems like this is working. So the first thing we checked is we noticed that it was an alternating series, so we had to make sure that we included that -1 trick in here. So you want to use either this or this if it's an alternating series, and you just pick which one depending on if you're starting with the positive or you're starting with a negative. Then you want to look at the denominator and the numerator separate sometimes, because sometimes they're set up differently. In this case, the bottom was being multiplied